All right, lines and angles, lesson 18. Okay, so what is a line? A line is a straight path, right? Now it can be limited by two endpoints, or it can go on for towards infinity in both the directions, right? Now there are different terms that you would use for each of the two types that I just mentioned. A line is a straight path that extends without any end. A ray is a part of the line that has one end point and extends in the other end as yeah, without any end, okay? And a segment has two endpoints in both the directions. Does that make sense?
Yeah.
So segment has two endpoints, ray has one endpoint, and a line has no endpoints. Now, the way you represent a line is basically you take any 2 points on the line, and if you call them A and B, then the line or the ray or the segment has different notation, right? So if it's a line, then you'll write it as AB this way, or you'll write it as BA, a line on top with both arrows. If it's a ray, then you'll represent it as AB, an arrow here. This cannot be interchanged simply because you have the extension on the side of B, right? And A is an endpoint, and therefore you write AB and the arrow must be in this direction. And then for the segment, you'll have AB and a dash on top. Okay, clear?
Yeah.
Okay, now we'll start talking about different kinds of lines, what's their relation, etc., etc. Starting with a plane. What is a plane? A plane is a flat surface that extends without any end. Two lines that are on the same plane can either be parallel or they can intersect. Okay, so intersect as in, so this let's say this is your plane. These two lines are intersecting. If the lines run like this, that means they are parallel, right? Have you heard parallel lines before?
Yeah.
Okay. Now, lines that are in different planes do not, different planes and they do not intersect are called skew lines. Okay. So if you take a horizontal plane and a vertical plane, right? And then you have one line in the vertical plane, one line in the horizontal plane, and they don't intersect, then those two lines are called skew lines. Okay, for example, your wall and your ceiling, wall is a vertical plane, ceiling is a horizontal plane. A line on the wall and the line on the ceiling which does not intersect will be called a skew line. The next concept is that of an angle. An angle is formed by two rays who have the same endpoint. That endpoint is called the vertex, okay, and the two rays are called the sides of the angle. Does that make sense?
Yeah.
Now, what is the notation of an angle? If you have two endpoints on the two rays, on the two sides, as A and C, and the vertex is B, then the way you write the angle is angle A, B, C, wherein the vertex should always come in between. Or you can also write it the other way. You can write it as C, B, A. Okay. Sometimes when the endpoint is not given and just the vertex is given, like in this case, you'll just write it as angle A. Okay. Sometimes the angle is numbered. At that time, you'll write angle 2. So these are the different ways in which an angle is represented mathematically. Now, an angle, what is the unit of measurement of the angle? It is degrees. Okay. One full circle like this represents 360 degrees. Okay. Therefore, a quarter turn will represent just 90 degrees. Any questions there?
No.
Okay. Now, different kinds of angles. An angle that lies between 0 and 90 degree is an acute angle. An angle that is 90 degree is a right angle. An angle that lies between 90 and 180 is an obtuse angle, and an angle that is 180 degrees is a straight line. So it's a straight angle. Now, if there are two angles such that the sum of those two angles forms a straight angle. For example, if I draw another ray here, this forms two angles, right? Wherein this angle plus this angle together give me 180 degree, correct? Then these two angles are called linear angles or linear pair. Okay? So if someone says linear pair, it means that the sum of those two angles is 180 degrees. Protractor is a tool that is used to measure angles. Have you ever seen a protractor before?
Yeah.
Have you used it?
Yes.
Okay, excellent. So essentially you put the center of the protractor at the vertex of the angle, and then you see where one of the sides will cross the markings on the protractor. Okay. Can you find the angle RST here?
$50 degrees.
Yeah. Okay, practice set. All the questions. Go ahead, one after the other.
A is a line.
Mm-hmm.
B is a ray.
Correct.
C is a segment.
Correct.
D is parallel lines.
Correct.
And E is perpendicular.
Perfect. Next.
CMD is an acute.
Okay.
CMA is an obtuse.
Mm-hmm.
AMB is a right angle.
Right.
AMD is a straight angle.
Correct. Or a linear pair. Sorry, straight angle. Next one, J.
Uh, 135.
How did you get to it?
I just did 45 times 3 because 45 times 4 would be 180, and it's supposed to be in the middle of 90 and 180.
Okay, so the other way of doing it is basically you've been given DMC, right? And you're supposed to find this angle, CMA, correct? And you know that DMC and CMA form a linear pair, isn't it?
Yeah.
So what you can do is you can just do that angle CMA plus angle DMC equals 180 degree because they are a linear pair, and therefore angle CMA plus DMC is 45 degree equals 180, and therefore you get angle CMA is 135 degrees. This is the way to do it. Okay.
Mm.
I'm just checking for a question that you haven't done before. Can you do this question? Fifth one.
Um, uh, 15 minutes per mile and 4 miles per hour.
Good. 4 miles per hour. Okay. Do this as well. The word problem.
I got 238,000 miles.
Okay. Next, polygons. Again, have you been exposed to polygons before?
Yeah.
Okay, interesting. I think they're covering stuff that you've done before, and maybe the later chapters have new things. Is that how this textbook generally works?
What?
My question was, you have done Saxon Math Course 2, right? So
Yeah.
even there were the initial chapters just a revision of Course 1?
Yes.
Okay, all right. Polygons. So what are polygons? Polygons are essentially closed single plane figures wherein they are basically formed by straight lines joining together, right? And the number of angles that are formed by a polygon is equal to the number of sides. Example 1. So remember, closed plane figures that are formed with straight sides. Example 1, which of these figures is a polygon?
Um, I think it's figure D.
Yes. That's because in A, there's a curved side, so that's not a polygon. In B, it's not closed, so it's not a polygon. In C, it's not in a single plane, right? It's a three-dimensional figure. And therefore, it's not a polygon. Only D is a polygon. A polygon is called to be a regular polygon if all the sides are of the same length and if all the angles are equal. So in example 2, which of the following polygons is not regular?
It's a D.
It's D because
Wait, I think it's A.
okay, you have to justify.
I don't know this one.
Okay, so what is a regular polygon? There are two conditions for a regular polygon. First is all the sides are of the same length. Okay. And the second is all its angles are equal. Okay. So in this case, in A, all the angles are equal, right? And all the sides are also equal. So it's a regular polygon. In B, all the sides are equal, all the angles are equal. It's a regular hexagon. C, it's a square, all sides are equal, all angles are equal. So it's a regular polygon. In D, though, all the sides are equal, but the angles are not, isn't it? Because
No, yeah.
this angle, these two are much smaller than these two. So therefore, this is not a regular polygon. Clear?
Yeah.
Okay, names of polygon. Triangle is 3, quadrilateral is 4, pentagon is 5, hexagon is 6, heptagon is 7, octagon is 8, nonagon is 9, decagon is 10, hendecagon is 11, dodecagon is 2. A polygon with more than 12 sides can be just referred to as an n-sided polygon. That is, if it has 14 sides, you'll say 14-sided polygon or 14 gun, right? N gun. So polygon with 15 sides will be 15 gun. Now, point where two sides of a polygon meet is called a vertex. So basically, in a square, for instance, each of these points where two sides meet, they're all called vertices. Now, a particular polygon can be identified by naming the vertices with letters of the alphabet. So if I name this A, B, C, D, then I identify this polygon as polygon A, B, C, D. Okay. You can start with any letter, but you have to either move in the anti-clockwise direction or you have to move in the clockwise direction. Does that make sense?
Yeah.
Okay. So in this case, excuse me. In this case, it'll be UVTS or it'll be USTV, right? These are the two names. Now, what are congruent figures, right? Congruent figures are those figures which have the same shape as well as the same size. Remember, congruent figures are those figures that have the same shape and they have the same size. It's okay the orientation is not the same. Orientation as in it can be sleeping, it can be standing, but as long as they are the same shape and the same size, they are still congruent. Now, let's say they have the same shape but not the same size. Then they are not congruent, but they become similar. Okay?
Yeah.
Now, congruency symbol, if you have figure A is congruent to figure D, then the congruency symbol is this. You write a tilde and two lines in the bottom. This is for congruency. Okay? Now for similarity, you just write this. Any questions here?
No.